Hi everybody, thank you for coming. And a few words about myself. My name is Anastasiia. Currently I live in Amsterdam. For 2 years so far I've been using Scala. And today I wanted to present you a topic about ScalaCheck and property-based testing in general, and how it can aid you in finding really bugs that it's hard to reveal. And I hope you'll start using it after. I'm working in Lunatech, and if you want to know more about the company, just come by after the presentation, I'll tell you more. So what is the problem? Usually we write some code, some functions, simple methods, and for example, this one takes integer as an input argument and just calculates the absolute value. So usually you want to test it also, and probably you would write something like this with assertion, and you would think of some corner cases like minimum value, maximum value, and 0, or maybe some few more cases. But the problem is that you would run the tests, everything would pass, and you would go to production, and one day everything would break, maybe. So let's see how it would look like in a console. So we would define the method, and we would manually check the absolute value for 0, 0 as expected, for the maximum value as expected, for a minimum value, bam. So we forgot that integers are not symmetric, and minimum value, you cannot actually take the absolute value and get the integer, the positive integer. But if you would use ScalaCheck, it would help you for sure to find this corner case. So what usually happens is we are relying on a limited set of data to test our application and to validate our assumptions. But our implementation might totally overfit the test set, and ideally would be generate like all possible inputs and validate every one of them, but that would like take ages to write the code and to run it, and yeah, it's hardly feasible. But let's say if our code can pass like 100 randomly generated test cases, then we can still get a pretty good level of confidence that our code works. So the main idea is ScalaCheck is that we check properties on randomly generated data, and this data created by generators. So ScalaCheck is a unit testing library, and it provides unit testing of code using property specifications with generated data. And also it provides test case minimization, which helps you to immediately spot like the problematic data. Also it supports custom data generators, which you would use for your own data types, and some collection of statistical information. You should keep in mind that ScalaCheck is not meant to replace unit testing libraries, and it can just add some more stuff to it, and like automatic test generation can save you some time, and developers can focus on defining the purpose of the actual test case, not just thinking about every case by themselves. Also, property-based tests provide a lot more tests for way less code, and then assertion-based tests. And also it can help in cases where you should like test the whole classes of test cases, and you just cannot write that many tests. ScalaCheck is based around the concept of properties and generators. And according to the ScalaCheck documentation, properties is a testable unit in ScalaCheck, while the generator is responsible for generating test data in ScalaCheck. So you generate some data by these generators, and then the property will check if it still holds true. Let's now try to define a simplest property. The simplest property-based test uses the for-all object with a function that defines the logic for the check. For-all takes a function as a parameter and creates a property that can be tested with the check method. And the function should return a Boolean. So here we define a name that so we understand what we are testing, and we want to check that for each integer we'll get the absolute value. So then, if you run the code, we'll see this one, and you can see that it failed, and it actually specifies with which exactly argument it failed. You can, of course, do more with properties, and sometimes you want to specify like the boundaries you want to use. You want to maybe filter it out somehow, and you can do it with the generators by generating the specific data you want, or you can use it in properties by defining which data it should select from the data generated by generators. So here we specify the range of our inputs, and obviously the test will pass because we don't have that corner case. But doing this is a bit dangerous because then you can miss and skip some cases that you would actually want to test. But if you're sure that in your implementation you will never use those corner cases, then why not? So now generators. Out of the box, ScalaCheck provides some generators for the basic data types, and also containers for them. And if you need something else, you can always write your own custom data generators, and you'll see that writing them actually is quite simple. So let's write our first custom generator. Let's say we have a domain object of a log entry, which consists of two values of strings, event and time. And we should write our own generator. So how I would do it is you're using the gen object from the ScalaCheck, and it provides you with a whole bunch of default methods. So you can already by default generate all sorts of data like that you would want to use, like basic data types. And since we are using strings inside, like it's quite simple. You just specify that it should be alphanumeric string, and it will generate for each of these values its own value, and then you yield it to the log entry. Done. If you would use a ScalaCheck with, for example, other unit testing libraries, you would probably have something like this. You specify the for all, and you pass the generator that you want to use. And for example, I want to check the serialization to JSON and from JSON. And it works. So here we can see more stuff that you can get from gen object, and so generates strings, numbers, lists of elements, and it can generate list of every custom element as well if you provide the generator for this type. Also, you can specify that you want specifically non-empty list, or you want a list of one element, or whatever you want. It's quite straightforward. And also, it has some commodity methods like choose, one off, and sum off. So it will choose, for example, the value from the range of values, and one off is used like mostly for enumerations, and sum off you can also use that for options, and sometimes you just need a constant. So now let's try to make our case class a bit more complicated, and we would add a source value of type source, which is enumeration. So how would we write the generator right now? We would use gen1 off and pass all the values that we want to choose from, and it would choose one of them. Simple again, the test would pass. Now I was thinking about like more complicated stuff. What could you possibly want to add? Boolean, option, or big decimal, and ScalaCheck doesn't have a generator, a native generator for the big decimal, so you would need to write it by your own, and a list of your some domain object as well. So this one is more complex, and as I said, ScalaCheck doesn't have the generator for the big decimal, so you would want to write one. So you can see it at the bottom. So you would want to choose one number from this range. So you specify the boundaries, and you use choose num method. But to use choose num method, it is necessary to specify the choose instance of this data type, and well, you just Google it. It's not that complicated to create one, and then it works. So now we can use a big decimal generator, and it was an option. So you use generator option of generator big decimal. So for Boolean, you would use one off, and just like for enumeration, just two options. And for the list of, it's also you specify list of, and then you can pass inside another generator. Actually, you can, like, it can be nested as many times as you want to get what you need. So that would also work. So this was like basically all bunch of functionality that you can get. Like, it's quite straightforward. And what I wanted to share today is also like my experience in working with it, and how it actually, what like nasty cases you can get, and how can you actually deal with them. My story is without a happy ending, but at least I will show you some code and how it like actually happened to get this. So I needed a generator for the daytime, and I came up with this maybe not the nicest solution, but it was working. So to construct the zone daytime, I need to use the instant, and I should have passed the zone ID. So I was choosing the instant from the number. I was creating it, and zone ID from all the available zone IDs. I was choosing one. Well, looks like working to me, but it wasn't. Actually, when we were running the tests, it appeared that every time that you serialize it to JSON, and everything works fine, but when you deserialize it back, then instead of the daytime type, you get string. Like, why would it happen? What could possibly go wrong here? And fortunately, with a ScalaCheck, you can see which exactly value caused your test to fail. So I was just looking at the values, and they looked perfectly fine for me. But then I found out that actually it was happening. Oops. Wow. It was happening only in case when you were passing the specific zone ID, which was GMT0. So what would you do if you get this kind of case? You Google, and then I found out this JDK bug. Like, what can you possibly do with a JDK bug? Like, what am I supposed to do? Should I fix it myself? Should I wait till it's going to be fixed? I don't know. Like, it will take ages probably, and how should I solve the situation? And how would you solve it actually? Like, it's probably unsolvable till it's get fixed. So what would probably each of us do? I just filtered it out. my tests pass, but then we also all realize that when this happens, actually it will crash. Like, what can we do with it? But we discussed it with our team, and we found out that actually no one is using GMT0. It's kind of a bit obsolete already. So, like, the chance was probably almost like impossible. So we decided to keep it like that. But if something would crash, then we would know where to look for. And another case. So we had a domain object of characteristics, and the onlyest way to see which exactly type of it was either it was Boolean, numeric, datetime, string, numeric array, or string array, was to see what value was inside the value field. And the problem was the same, that while deserializing, some numeric array characteristics, and they were decoded as a string array characteristics. And in this case, we were losing like lots of information because apart from this value, you had like lots more. And this was like a real problem. And we didn't even know about this till we ran the tests. And it was actually already in production. Fortunately, nothing bad happened, but still. So the problem, as appeared to be, it was happening only when you were passing the empty list in the values field. And then, obviously, how can you know which type it is if it's an empty list? Like, it cannot be list of int or list of string, it's just empty. So there was no way to find what was exactly the type. And actually, it was the big issue because actually we couldn't think of any solution. And what we proposed to our customer that we should add another field which would specify which exactly type of characteristic you want to use. But they were like, as always, it's a bit hard to explain how big is the problem. And the customer was saying, no, we're not going to introduce any more fields because it will impact more teams, more countries. And you should deal with this one like the way you want. But there is no solution. Like, what can we do? So we just decided that whenever everyone passes the empty array, we would just throw the exception that it's impossible. We like don't accept the empty arrays, and like the customer said that it will never happen. Like values should be full, otherwise, like these characteristics in general make no sense. So we had to trust our customer and just go with it. So my story of these bugs are not really happy. There was no way to fix it. In one case, I just avoided the problem, and another way, we were just throwing exceptions and instead of handling the situation. But at least with ScalaCheck, you might find these cases and deal with them, or at least be aware of them. And if shit happens, then you know where to find the problem. Thank you very much, and that's it. Questions?
Are there any examples of testing the generic functions?
What do you mean generic functions when you don't know the type?
Yes. Or higher order functions.
I need to look it up.
Okay.
So, thank you for questions.
Thank you all.